All right, here's for day 2, numbers 26 through 30 and 37. So 26, letter A, we're finding the, what are we finding? What does it say? Assume ddx of sine is cosine and ddx of cosine is negative sine. Prove each of the following. So we have to prove. Let me write. That's my instructions. Okay, so we have to prove each of these is true. Okay. All right, well, let's start by breaking up cotangent. We want it to match with negative cosecant squared. Okay, so ddx of cotangent is the same as cosine over sine. Okay, well, now I have a quantity divided by a quantity, so I can use quotient rule. So that would be low d high minus high d low over low squared. So low, derivative of the high, derivative of cosine x is negative sine x, minus high, d low is cosine x. That was horrible. All over low squared, so sine squared x. Okay. Well, sine x times negative sine x is a negative sine squared x. Negative cosine times cosine is negative cosine squared x. All over sine squared x. Okay. This looks like sine plus cosine squared, so we need to factor out that -1. And it is. You guys remember what that equals? Sine squared plus cosine squared equals 1. So I can replace this whole thing with a 1. So -1 times 1 is just -1. And 1 over sine would be cosecant. So 1 over sine squared would be a negative cosecant squared of x. And hey, that's what we needed to get. Check. We proved it. Letter B. Same sort of thing. Let's switch out cosecant. Cosecant is the reciprocal of sine. So it would be same as 1 over sine x. Okay. Again, we have a quantity divided by a quantity, so quotient rule. Low d high minus high d low over low squared. So low, derivative of 1 is 0, minus high, derivative of the low, derivative of sine is cosine, all over low squared, so sine squared x. I don't know why I put parentheses, I didn't need them. 0 times anything is 0. -1 times cosine is negative cosine over sine squared. Anytime we have a cosine over sine, that is a cotangent, so let's split it. So we have negative cosine x over sine x times 1 over sine x. And so negative cosine over sine would be a negative cotangent, and 1 over sine is cosecant. So negative cotangent cosecant is the same as negative cosecant cotangent. Woohoo, we got it. Check. Proved. We proved it. Number 27 is basically saying to show that the graphs of y equals secant of x and y equals cosine of x have horizontal tangents at x equals 0. Remember, horizontal tangents, those are horizontal lines, and horizontal lines have a slope that are 0. So basically, slopes are 0 at x equals 0. Okay, and we're finding a tangent line, we're taking a derivative. So let's start with secant and take its derivative. The derivative of secant is secant tangent. If you don't remember these still, put them on an index card, look them up. Train yourself to remember them. Okay, and we're looking at x equals 0. So that means I could plug in a 0 for that derivative function. So secant of 0, tangent of 0. And when we're talking about 0, we're talking about the degree. So the degree is 0. So I'm going to draw a quick little unit circle sketch at 0 degrees right here, and that is the coordinate 1, 0. Okay, so cosine is 1, sine is 0. Well, secant is the reciprocal of cosine. Well, the reciprocal of 1 is still 1. Tangent is sine over cosine. Sine is 0, cosine is 1. 0 divided by 1 is 0. So 1 times 0 is 0. Okay. So it said show that the graphs have horizontal tangents at x equals 0. So we're getting a derivative at x equals 0 to be 0. So far, so good. That shows it. Now let's take a look at cosine of x. So y prime equals, well, the derivative of cosine is negative sine. And let's find that derivative at an x value of 0. So negative sine of 0. Well, we know sine of 0 is 0. And negative times 0 is 0. So the derivative, or cosine of x has horizontal tangents also at x equals 0. Okay. Another way to show number 27 is graphically. So I'm going to show you really quick how to show it graphically. This was analytically using some algebra and trig, but graphically, we would look at the cosine graph and the secant graph. We know what cosine looks like. It starts up here, up at -1, and then goes down, down, up, up. Forever and ever and ever, right? This is cosine. So at an x value of 0, that would be at the origin right there. We do have a horizontal tangent there. So the slope of that line would be 0. So that's showing it graphically. Pretty much we're looking right there. And then for secant, so secant, remember it's where you flip the waves on the cosine. So let's see, secant, I should have drawn it below. That means up here, where I have 1, it would be like this. Okay, and then at the next one, that's second line. It would look like that. So at an x value of 0, yeah, we'll have a horizontal tangent there. There it is. This is the secant of x graph. Okay, so graphically, it's actually a little bit easier because it's less things to write down. You just have to draw a picture. Okay, and that's 27. Number 28, show that the graphs of y equals tangent of x and y equals cotangent of x have no horizontal tangents. Okay, so when we think tangent of x, we should be thinking something like this. And when we think cosine of x, it's similar, but it goes like this. Okay, just the opposite direction. So there aren't any horizontal tangents. These are all going to be increasing, increasing, increasing till they get to vertical tangents. All right, that's why there's asymptotes between all the tangent graphs and all the cotangent graphs. Okay, so we know that it doesn't have any horizontal tangents. So let's take a look at it. Let's do the derivative of tangent of x. Okay, and we know that the derivative of tangent is secant squared. Okay, and we know that secant squared is never going to be 0. It's just going to be undefined, only undefined, because they're going to be approaching, those slopes are going to be approaching a vertical line. Same thing's going to happen with cotangent. It's facing the other way, but it still has the same sort of shape, so it's going to have the same behavior. So the derivative of cotangent is negative cosecant squared. And we know that this is never 0 also. It's going to have the same thing. It's only undefined. 0 is not the same as undefined. We can have a 0 in the numerator, just not in the denominator. And getting the 0 in the denominator is why we're getting undefined, because they are going to be vertical tangents, vertical lines that are tangents. Okay. So this one was a deep conceptual problem. You have to really know your tangent and cotangent graph and know that there won't be any horizontal tangents and why. Number 29, find the equations for the tangent and normal lines to y equals the square root of 2 cosine x at pi over 4, comma 1. Okay, so we're finding equations for a tangent line, first of all, and that means that we need to take a derivative, and we need to plug in that x value. They gave us the y value. How nice of them. All right, so let's do this. So I have two quantities, square root of 2 times cosine of x, so I'm going to need to use good old power rule, or product rule. But the square root of 2, though, is a constant, so I technically don't even need to do that. I could just find the derivative of cosine. If you try to do power rule, you should still get the right answer, though, but it's going to be quicker to do it this way. Okay, so y equals square root of 2 times the derivative of cosine is a negative sign. Okay. And there's not much else I can do to simplify that. So let's just go ahead and plug in pi over 4 for x. So y prime of pi over 4. Okay. And pi over 4, we think about our unit circle. This is where pi over 4 is. It's that 45-degree angle. And we know that the cosine is square root of 2 over 2, and the sine is square root of 2 over 2. So sine of pi over 4 is square root of 2 over 2. So I have the square root of 2 times negative, because there's a negative out front, square root of 2 over 2. And we can just multiply across. Or square root of 2 times negative square root of 2. Radical times itself means the number inside gets to come out, but there's going to be a negative out front because of that negative. So negative 2 over 2 is equal to negative 1. So that's the slope at that x value. So now I'm ready for the equation of the tangent line. So negative 1 times x. The x value is pi over 4, so minus pi over 4. And the y value is a positive 1. And then for n of x, the opposite reciprocal of negative 1 is a positive 1. And then it has all the other same stuff because they're perpendicular to each other. Not so bad. Number 30, find the points on the curve y equals tangent of x on the interval negative pi over 2 to positive pi over 2, where the tangent is parallel to the line y equals 2x. All right, so if the tangent line is parallel to this line, that means it's going to have the same slope as this line. So that means that the slope of the tangent should be 2, which means that the derivative should equal 2. Okay, so let's start with taking that derivative. So y equals tangent of x, and let's take a derivative. Well, the derivative of tangent is secant squared. Hopefully those are starting to stick a little bit better the more you try it out. And, okay. Now we know that the derivative should equal 2. So set it equal to 2. And let's solve for x. So we're going to need to take a square root on both sides to undo the square. So we're going to get plus or minus square root of 2 equals secant x. Okay. So secant x equals plus or minus the square root of 2. So where on the unit circle would that be? Well, let's draw a little picture. So our interval is from negative pi over 2 to positive pi over 2. So we must be going around like this. Okay, so we're using this part of the unit circle. Well, where are there radical 2's in the coordinates? And we have to remember secant is the reciprocal of cosine. Well, the one that has radical 2's in all of them are the pi over 4's. We have pi over 4 over here and negative pi over 4. Because those coordinates are square root of 2 over 2, square root of 2 over 2. And these ones would be square root of 2 over 2, but the y is negative down there, so negative square root of 2 over 2. Okay. So secant is the reciprocal of cosine, so it's basically where cosine is square root of 2 over 2. And since cosine is square root of 2 over 2 in both of these spots work. So there are 2 points where it's going to work. So that is going to be at an x value of pi over 4 and an x value at negative pi over 4. Okay. So what are the y values? Well, to find the y values, we have to plug in these x values at the original equation, and that is tangent of x. So y equals tangent of pi over 4. Well, tangent is sine over cosine. Sine over cosine, anytime you have a quantity divided by itself, it's going to equal 1. So the tangent at pi over 4 is going to equal positive 1. And the tangent at negative pi over 4, well, we have negative square root of 2 over 2 divided by square root of 2 over 2 is going to be a negative 1. Okay, so the points where the tangent is parallel to the line y equals 2x are at pi over 4, positive 1, and negative pi over 4, negative 1. And that's number 30. So really digging up those trig memories. Hopefully they're still there. If not, well, you'll have to remember them fast. Okay, and then number 37. Is there a value of b that will make g of x equals to x plus b where x is less than 0 and cosine of x where x is greater than or equal to 0, continuous at x equals 0, differentiable at x equals 0, and we have to show our reasoning behind that, okay? So first of all, when we're trying to say if it's continuous or not, that's where you set the 2 pieces of the piecewise function equal to each other. So x plus b equals cosine x, kind of like the FRQ, actually exactly like the FRQ we did a couple quizzes ago. Okay, and we know this is at an x value of 0, so we could plug in a 0 for x. Cosine of 0, what is cosine of 0? Well, at 0, we have the point 1, 0, so cosine was 1, sine is 0, so cosine of 0 is 1, so b equals 1. Okay, so since we have a value here, we can say that g of x will be continuous if b equals 1. At x equals 0, since g of 0 is defined, it exists, and if it's defined, that means the limit as x approaches 0 from the left of g of x equals the limit as x approaches 0 from the right of g of x, and that's going to equal wherever g of 0 is. Okay, so it is continuous. Is it differentiable? That's where we take the derivatives and set them equal to each other. So we're going to have the derivative, the d dx of x plus b. Is that going to equal the derivative of cosine x? Well, let's find out. We know that the x value is 0, so we can plug in zeros. 0 plus b is just b. And we know that the derivative of b would just be a 1. Okay. And then d dx of cosine x, well, that would be a negative sine x. Okay. And let's try that sine of 0. Well, sine of 0 is 0. Well, negative times 0 is 0. 1 does not equal 0. So we didn't get a true statement. So this is not differentiable. Since the limit as x approaches 0 from the left of g prime of x, the derivative, does not equal the limit as x approaches 0 from the right of g prime of x. All right, and I keep going back to this because I don't think I explained the derivative of this right. I didn't plug in a 0 for x yet. The derivative of x is a 1 and b is a constant, so the derivative of a constant is 0, so that's why it was 1. And that was bothering me because I didn't say it right the first time, so I wanted to make sure that I explained it and said it right. All right, that's it. Sorry this one was a little bit longer, but it's still under 22 minutes. Not so bad. Bye.